All right, let's go ahead and do a few more. So we got 7. This one's only different because they didn't draw a picture for you. So I'm going to go ahead and just roughly draw a circle, very roughly. Here's the center of our circle. Now, when they name the sector, they actually tell you in the middle what the center should be. So this should be, should be B. And then A and C should go on the edge of the circle, like so. Well, they tell us the diameter. Now the diameter is not what we want. We want the radius. So the diameter is 4 inches, so the radius should be 1/2 of 4 inches or 2 inches. They also do give us the measure of the arc, which is also the central angle. So I'm going to put it in the central angle as 135 degrees. So we're actually good to go. We're trying to find this area right here. So we can go ahead and say, well, our area is 135 over 360 multiplied by our area. So pi times our radius squared. That's a multiplication. There we go. And then 135 over 360, if you simplify that, gives you 3/8. So area is 3/8 multiplied by 4 pi. You can put that over 1 and multiply straight across. So you get 12 pi over 8, which gives you, they're both divisible by 4, so you get 3 pi over 2. So the area of that sector is 3 pi over 2. And then our unit would be square inches. Okay. Now, they didn't specify if we were supposed to give the exact or the approximate, so let's go ahead and practice finding the approximate. So 3 pi divided by 2, you can also put 3.14 in if you want, is approximately 4.71 square inches. And there's that. So with that said, let's go ahead and go on to number 8. Number 8 looks really complicated, but it's actually exactly the same thing we just did. Okay, so I'm going to highlight kind of a few key features. So we've got this irrigation system that consists of 400 meters of sprinkler equipment that rotates around a central pivot point at a rate of once every 3 days. Okay, so what that's saying, I know that sounded really complicated, is if we have this circle right here, it takes 3 days to get all the way around the circle. Okay. It has a diameter of 800 meters. So before we even continue, we never want our diameter when it comes to area of sectors. We want our radius. So I'm going to go ahead and find 1/2 of 800, which is 400 meters. Okay. We need to find the area of the sector that is irrigated by the system in just 1 day. Well, remember, it takes 3 days to get through the whole thing. So that means day 1, 2, 3, we're going to be splitting this into 3 equal pieces. So we're going to be finding the area of this right here. The cool thing about this problem is we don't need to know the angle. We just need to know what the fraction is that we're splitting the circle into. The angle is just there so that we can find that fraction. So we already know the fraction. It's 1/3 of the whole circle. And then we're going to multiply that by our pi, our area. So pi times the radius squared. If you wanted to, you could actually just type this whole thing into your calculator. Since word problems, you usually don't give exact answers. You usually give approximate answers. So I can just type this whole thing in, and I get approximately 167,551.61, and we're dealing with meters, so we'll say square meters. And that would be the answer. So that's the last part of the notes. I do want to have a couple additional problems that might be worth looking at. For example, there's this one. We've got a circle. We want to find the radius of the circle that has an area of 50.27 square inches. Notice I underline that because we need to remember that area is always the unit for area is always squared. Now remember, area is pi r squared. So area equals pi r squared. We know the area is 50.727, and then you can just solve this equation. In order to do that, just divide by pi. And we're going to go ahead and do an approximate answer. So go ahead and type in 50.27 divided by pi in your calculator. You get 16.001 equal to r squared. And then you can take the square root of both sides. Now, usually when you take a square root, you should add a plus or minus. But radius length should always be positive because we're talking about a distance here. So your radius is going to be about 4 inches. Now, the radius is not an area, it's just the actual length, so we do not square the units. Okay, one last thing. I mean, you don't have to follow this, or follow along with this one, but I think it's an interesting thing. You might be asked to find the area of both sectors, so both the small one versus the large one. And large, sweet. So I just wanted to show you something quick you can do that. So first off, the small one, this is a 90-degree angle. If it's a 90-degree angle, you should know that that's 1/4 of the circle. And then you can multiply that by our area, pi times 6 squared. Now, if you didn't know 90 degrees was a fourth, then you would do your normal theta over 360, or 90 over 360, and you'll realize that is equal to a fourth. And that's how I got 1/4. Well, from there you'll get area is a fourth times 36 pi. And when you simplify that, you get that the area is 9 pi, whatever our units, square feet. There we go. Okay. Now, this is why I think this problem, I just wanted to bring this up. The large area, you do not need to actually find the angle, the other angle for the measure, I should say, the measure of the major arc. We don't need to find it. You can just use your information that we already have provided. The area of the full circle, so this is the full circle. Whoa. Sometimes I don't know how to write. So the full circle was a little better. Oh well. We know is pi r squared, so pi times 6 squared, or 36 pi. Well, and we know that the area of this region right here is 9 pi. So to find the large one, we could just do 36 pi minus 9 pi and get 27 pi square feet. No need to go through the full long process. It's just a simple, just 36 minus 9, and you get your answer.